Hello and welcome. The video today is on further mechanics. That is not the straight mechanics for straight maths, not the next module usually on mechanics, but normally, depending on the board you're doing, the next mechanics module. But it's actually a very simple question. This has gone into one of my papers. You can see the question in here, so I will copy the important things. So it's actually quite a very straightforward question. So he's talking about a particle which starts from rest and moves on the x-axis with acceleration of this magnitude, which is acting in the direction of x increasing. So the information that we're being given is we have acceleration x double dot, and it's positive in the direction of x increasing with magnitude 60 over t plus 3 all squared. And there's a condition that has been mentioned there, starts from rest. So when t is equal to 0, rest, v is equal to 0, and arbitrarily, I apologize for my cough, as per usual, this is arbitrary. I can decide to call the origin at the place on the x-axis where I set the clock equal to 0, unless it's giving me a specific condition, which it doesn't here. If I need something, I can actually go ahead and say, okay, there's the x-axis, and at this point, I decide to set the clock equal to 0, purely because my velocity is 0, and I call this place the origin, just here. Pardon me. Find an expression for the velocity of the particle in terms of t. Straightforward. Velocity in terms of time. We're going to write the acceleration as dv by dt is 60 over t plus 3. Separate the variables. 1 dv is equal to 60 over t plus 3 dt. Integrate both sides. I'm going to put the conditions in. Do they want an expression? Yeah, an expression. So when t is equal to something, there's a v to go with it. So this is going to be the condition. 0 for the t, 0 for the v. And if I want an expression, when t is t, v is v. Integrate. V from 0 to v is equal to, integrating that, I missed there, was it cubed or squared rather? Why did it become cubed there? I will never know. So it'll be squared. And if I integrate that, it will be a minus, is going to be 60 over t plus 3. Let's double check it before we go to the next line. If I differentiate that, it's to the minus 1. The minus will come to the front. We can make that into a plus, and this will go to the minus 2, which is what I'm saying in there. And of course, this is going to be v minus 0. V for v is v. 0 for v is 0. And what I'm going to do here, I'm going to do it on this line. I don't like this minus. So I'm going to lose it, and at the same time reverse the limits of integration. I hope you're aware of this fact. So when I'm putting 0 in there, I'm going to get 60 over 3, which is 20, minus, putting t for t, 60 over, t plus 3. So an expression for the velocity in terms of t, I'm going to use an orange pen, is in fact v is 20 minus 60 over t plus 3. If you didn't quite follow what I've done there with the limits, do not worry about that. Do your integrations plus c, put your condition. You will find what your constant ought to be. It's going to be this 20 or something. And then of course you get to the same answer. You don't need to do this particular technique. This is actually correct what I'm doing, but it's not being taught, and I've never really seen it in books these days. Okay, Part B. Show that the distance covered by the particle in the first 6 seconds of its motion is given by 60 bracket 2 minus the log of 3. So we need to involve distance, which is x, and time. So we need to take the velocity expression, which of course we have now, and write it as dx by dt. And of course use the answer that we got in part A, because that's part A and part B. As I told you, this question is very easy. It would have been a little bit more challenging perhaps if it just asked you just straight for this bit here, so you had to work out this for yourself. Okay, separate variables again. 1 dx, so I'm looking at this bit here. We can remove that, so if it's confusing us, is equal to 20 minus 60 over t plus 3 in a bracket, because all of that is now dt. And now I can integrate both sides of this equation. Again, I'm going to use limits, so I'm not going to have constants of integration. So when t is equal to x is equal to, so when t is equal to 0, because it says in the first 6 seconds of its motion, so when I set the clock is equal to 0, I chose x to be the origin. And when t is equal to 6, I don't want an expression, I want the actual answer now. Therefore, I can put on the top limit a number, and this will find me the x associated with 6. So integrating both sides of this equation, integrates to x, 0, to x, and this will now is with respect to t, so it's going to be a 20t, and this of course will give me a log minus 60 log. I'm not going to use mods there, t plus 3, and the limits 0 to 6. X minus 0, x for x, 0 for your x. Putting 6 in there, I'm going to get 120 minus 60 lots of the log of 9. That's on the top limit. Minus, when I'm putting 0 there, this is dead. And when I'm putting 0 in the log, I'm going to get minus 60 the log of 3. And that is just a tidy up. The question, say, to get to that form, I don't think there's anything challenging about that. It's quite silly, really. Let's get the logs out. So I'm going to write the, first of all, minus 60 log 9 plus 60 lots of the log of 3. Factorize out of that, first of all, the 60. We can get 2. And we're going to get, I'm going to write this as a, it doesn't really matter which way we do it. Let's leave it as it is. So minus the log of 9 plus the log of 3. So x is equal to 60, bracket. These two logs now is in fact the log. So I'm going to write it as plus the log of 3 minus the log of 9. So you can actually follow what I'm doing. X is equal to 60. 2 plus log 3 of log 3 minus log 9 is the log of 3 over 9, which is the log of a third. And of course, the log of a third, if you flip its argument, you will get, of course, the log of 3, but with a minus coming to the front. I hope you're familiar with this thing here. Forming your straight maths is not anything too complicated. The log of a over b is minus the log of b over a. So in case of reciprocal, usually fractions, it does help because, of course, if you flip it, it generates a minus to go to the front. Okay, as promised, that was a very simple question. I did, why am I doing this type of questions? And I don't know if you noticed recently, I have been doing some of this. When I'm doing solutions now from some of the papers that I'm adding, and I pick a sample of some interesting questions, try to build up a few questions perhaps for the people that might be finding this kind of stuff useful or they need some kind of assistance. Okay, I'm going to be signing out. I'll see you real soon. Bye for now.